So this is our quiz review. I'm going to hand you a piece of paper that looks remarkably like this next time. When you're doing simplifying and verifying, it's a series of replacements. It's what can I replace this with? And you want to make everything sines and cosines if you can, so that things will cancel out. So looking at the first one, that numerator already is cosine. So I would just leave it alone, but I would put it over 1. Anytime you're not changing something, it's good to put it over 1 because you end up with a lot of fractions in these things, and then you can see what's canceling out. All right, big fraction bar. What can we replace cotangent with? Cosine over sine, good. So now it's all in sines and cosines, which is good. Whenever you divide by a fraction, you're going to multiply by reciprocal. All right, so it's going to be cosine of theta over 1 times, and then you're going to flip this over, sine over cosine. And sometimes, I just thought of this, so I'm going to say it. Sometimes with these, when it says simplify, people are like, well, how far do I have to go? Am I done? That is a question I will answer while you're taking a quiz. If you call me over and you're like, am I done? I will tell you yes or no. So if you aren't sure, just ask me. I'm not telling you how to do the problem. I'm just letting you know if you're done or not. All right, so then what's going to happen here? Yeah. Cosines cancel. You get sine over 1, which is just sine. And so that's as simple as that can go. Cool. All right, looking at the next one. Do you see how this whole thing in parentheses is squared? That means that you need to write it twice. You have done this before very successfully. You've been good at it. It's just now there's a trig function in there, and that does kind of throw people off. But just, did you remember when it was like x plus 3 times x plus 3? You distributed everything. Same concept, right? 1 times 1 is 1. The outsides give you 1 sine of theta. The insides give you 1 sine of theta. So what is that together? Yeah, 2 sine of theta. You now have 2 of them. And then sine times sine is sine squared. Good. And you have to put the squared in the middle like that. We had that conversation. If you put it after the theta, you're not squaring sine, you're squaring just the angle. All right, and then what was at the end of that? Minus sine squared. Oh, so what's going to cancel? Yeah, the sine squareds, and then this is your answer. Cool. All right, the next one has those 90 minus thetas in them. Those are co-functions. So you just add a co or remove a co. So what does this one say? Like, how do we say that? That's cosecant. So if you remove the co, it's just secant. And then this one is sine. You would have to add a co, and it would become cosine. Perfect. So we got rid of the 90 minus whatever. That's good. Now you want to replace it all with sines and cosines. What can you replace secant with? 1 over cosine. And then I would rewrite this just as cosine over 1. You're not changing it. If you don't change something, usually putting it over 1 is a good idea. And then what happens to all of that? Yeah, everything cancels. And so your answer just comes out to be 1, which I always think that's interesting when you get like just a number. All right, last one of these. What can I replace cotangent with? Good, cosine over sine. Perfect. And then we've got cosine, so I want to put that over 1. Remember, if you're not changing something, put it over 1. Big fraction bar, what can I replace cosecant with? Yep, 1 over sine. So when you divide by a fraction, that's the same as multiplying by the reciprocal. I don't have enough space to write the whole thing over again. So I'm actually just going to put a little multiplication dot and flip this over because I ran out of room. So instead of 1 over sine, it's sine over 1. So we're going to just ignore this. All right, so does anything cancel? Sines cancel. Why do the cosines not cancel? Well, it's not 1 on the numerator, 1 on the denominator. So instead, we're just going to multiply them together. So cosine times cosine is cosine squared. And then that's as simple as it can get. But again, if you're not sure, just ask me. That's a question I can answer. Am I done? I can tell you yes or no. Now verify, you're not doing anything different. It's the same as 1 through 4, except the answer's on the paper, which is kind of nice, right? It's like having the answer key be given to you on the quiz. You start with the more complicated side and you work with it until you get the less complicated side. So which side would we start with here, left or right? Left, okay. Do you see the negative in there? That's even and odd. The even ones turn positive, the odd ones turn negative. So is tangent even or odd? Odd. So it is going to turn negative. So it's negative tangent of theta times cosine theta. What can you replace tangent with? Sine over cosine. And that negative is just going to hang out front. All right, and then the cosines are going to cancel, and you get negative sine of theta, which, oh my goodness, is what it says right there. Isn't that cool? So it's like the answer's on the paper, which is nice. All right, here, I realize it looks like the right side is the more complicated side, but it's actually the left, because you have that subtraction in there. And you'll see where I'm going with this after we do like the first step. Let's do some replacements. What can you replace cosecant with? 1 over sine minus, and then you can replace cotangent with cosine over sine. And then I was about to say you need a common denominator, but what's actually kind of nice about that? It's already a common denominator. I usually circle the numerator stuff because that's what you're putting together. And it's going to be 1 minus cosine over sine, which, oh my goodness, is what it says right there. I feel like that one looked really scary and then ended up being not too bad. Which side is the more complicated one here? Yeah, definitely the left. When you see those squareds in there, you want to think about the Pythagorean ones. So let's concentrate just on the numerator for a second. I realize, or a lot of you like, hey, let's cancel those out. You actually can't do that. Don't cancel those out because it doesn't take into effect the 1 there, right? So let's look at just the numerator. Cosecant squared minus 1. Look, if I have cosecant squared and I subtract 1, what can I replace that with? Cotangent squared. Good. So I'm going to replace that with cotangent squared. And now we want to turn it all into sines and cosines. So I can replace cotangent squared with cosine squared over sine squared. Cotangent is cosine over sine. You're just putting squareds in it. That's all that is. Huge fraction bar. And then what can we replace cosecant squared with? 1 over sine squared. And then what's going to happen? Sines are going to cancel. You get cosine squared over 1, which is just cosine squared. And holy moly, that's what's on the paper right there. There was no major like complaint. Actually, you guys have been really cool about these identities. Usually it's the thing everybody complains about, but you're all just on board and it's awesome. All right, go ahead and flip over. This is where you're going to use your little formula sheet. So you've got all your sum and difference, double angle, half angle identities on here. So look at this one. You want to find the identity that has sine and a plus sign in it. So do you see how that's this one right here? And please don't write on this because again, I'm going to take it back from you and use it with my other class and then I'll give it back to you on the quiz. So do you see how that's this one? Okay. A is going to be the 7 pi over 6. B is going to be the pi over 3. So let's like just read. You just basically have to read. When you have a formula sheet, you just read it. So it would be sine of A, which is 7 pi over 6. So sine 7 pi over 6. Cosine of B, which is pi over 3. And then what comes next? I want you guys to just read. Because if I read to you, it's not going to do you any good. What comes next? Plus. Cosine of A, which is 7 pi over 6. And then sine of pi over 3. Now we're going to draw the triangles. Okay. Oh, and I did leave you enough room. So off to the side here, kind of want to write below. I'm going to draw it down here. What quadrant is 7 pi over 6 in? 3, good. Your reference angle is pi over 6. What goes across from that? One-sixth is the little one. 1/2, good. The other one, square root of 3 over 2. And they are both negative, good. All right, and then what quadrant is pi over 3 in? First. Across from pi over 3, you square root of 3 over 2, other side's a half, everything's positive. And then you just use those to fill it all in. So sine of 7 pi over 6, this first one, you're going to look at this picture. Which one of these is sine? Yeah, the negative 1/2, good. And then you're going to do cosine of pi over 3. So you're going to look at this picture. Which one of these is cosine? 1/2. Plus, all right, cosine of 7 pi over 6. So look at this picture. Cosine's the x part of that. So negative square root of 3 over 2. And then sine of pi over 3, square root of 3 over 2. So when you multiply fractions, just multiply the numerators, multiply the denominators. Negative 1 times 1 is just negative 1. So it's negative 1. 2 times 2 is 4. This is plus a negative, so I'm actually just going to write minus. Oh, square root of 3 times square root of 3. What's that going to be? It would be square root of 9, which just is 3, right? And then 2 times 2 is 4. That's kind of interesting. The root went away. So what does that come out to? Negative 1/4 and negative 3/4. Yeah, just be negative 1, right? 1/4 and 3/4 makes a whole. I'm going to leave this one for you guys, and I'll fill it in and post it on Schoology. Only thing I want to say about this, do you see that negative there? It does not mean this angle is negative. A is going to be pi over 4. B is going to be 2 pi over 3. That negative just tells you which formula to pick. So you would pick the one that has cosine and a negative. Do you see that there? And if you want to try this at home, and I've taken this formula sheet from you, where else can you find these formulas? Like Google it. Sum and difference formulas. You can find it. I'll fill that one in for you because I'm going to put you all to sleep. All right. Given that tangent of A equals 7 over 24, and your angle is in quadrant 3. All right. So off to the side here, we're going to draw a triangle in quadrant 3. This is not on the unit circles. This is back to SOHCAHTOA. So your opposites, adjacents, and hypotenuse. Tangent is what over what? Opposite over adjacent, good. So 7 goes there, 24 goes there. It is one of the locker combinations. I'm going to see if anyone remembers it. 7, 24, 25. Now I actually need to fill in something else there. Negatives, good. So that's your like work. It says find cosine of 2a. So get out your handy formula sheet. Cosine for the double angles has 3 different ones. Do you remember me telling you what to pick? Just use the first one. If you're like, no, I don't want to use the first one, you'll get the same answer. It actually doesn't matter. All right, but I'm just going to use the first one. So it's cosine squared minus sine squared. I'm just going to write it out blank like that. Cosine squared minus sine squared. So looking at your picture, cosine is adjacent over hypotenuse. So that's negative 24 over 25. And then sine goes in this one. Sine is opposite over hypotenuse, so negative 7 over 25. On the quiz, because it's non-calculator, which triple do you think I probably gave you? Okay. But does anyone happen to know 24 squared? I know you have them memorized up really far. I don't actually know that one. It's 576. Why is it positive? Negative times a negative is a positive. Does anyone know 25 squared? That is 625. Minus, now this is still minus. This negative right here, this part turns positive. So that would be positive 49 over 625, and then you would just subtract those. I don't want to do that wrong in my head, so I'm just going to type it in real quick. It comes out to 527 over 625. Again, on your quiz, I'll pick littler numbers, so you'll be able to do it without a calculator. All right, and then last one. Tangent of A is 12/5, quadrant 1. I love quadrant 1. Everything is going to be positive. So tangent is opposite over adjacent. Do you remember this one? 5, 12, 13. Good. All right, so it says sine of A over 2. These all have plus minuses depending on what quadrant. I made it quadrant 1, so it's going to be what? Positive. So just basically ignore the plus minus there. So it's going to be square root of 1 minus cosine over 2. So draw a great big square root. I can't really have my formula sheet and this up here at the same time, so you'll have to look at it. 1 minus cosine. All right, so looking over here, what's cosine? What over what? Yeah, 5 over 13. And then that whole thing is over 2. Now you have to simplify that down. What did I tell you to do next though? Do you remember what we did? Yeah, make the 1 13 over 13. Because then you can subtract them. So 13 thirteenths minus 5 thirteenths would be 8 thirteenths, and then that's over 2. Now, if you divide by 13 and then you divide by 2, you have actually divided by 26. Oh gosh, and then that reduces 8, 26. They'll both divide by 2. So what would that be? 4 over 13. Not done. What's your square root of 4? 2. Still not done. I'm sorry. So it's 2 square root of 13 over 13. You guys have such good attitudes about it. No one complains. It's all fun.